So now we have, we've practiced a little bit with that differential operator notation. Just remember that d was represented by d, the derivative with respect to t, okay? And now, let me see if I can sell you on why this notation, this operator notation, although not needed, you could approach this without it. I do think you'll find that it's a lot easier to solve these systems with this notation. Ready? Let's jump in. So let's start with where I've gone in the problem so far. So this, let's look at this first equation. So that's x prime of t is equal to 3x of t minus 4y of t plus 1. Okay, so what we're going to do is we're going to isolate the functions of x as well as y. Okay, in other words, we're going to keep this 1 where it is on the right-hand side of the equation, and everything else is going to be moving to the other side of the equation. Now with equation 2, again, since we're isolating the functions of x and y, anything with an x or a y is moving to the left-hand side of the equation. So let's see if you can follow me here. So we're still left with the 1 was left on the right side of the equation, and the 10t is left on the right side of the equation. Okay, so you can see how our systems are starting to get a little bit, they're starting to get a little bit cluttered. So what we're going to do right now is we're going to take this system and we're going to write it in that operator, d operator notation, right? Using that differential operator notation. So let's see if you can follow me here. All right, so let's start with the x's. We have x prime and we have negative 3x. So we can think about that as, see if you agree with me. So that would be d minus 3, and that's all operating on x. And of course, x itself is a function of t, right? And then we would have plus, well, 4y of t would just simply be 4y. And all of that is equal to 1. Are you with me on that? Well, as always, if you start to second guess yourself, if you think about distributing here, so not distributing, think about operating here, d operating on x would be x prime, and negative 3 on x would be negative 3x of t. Okay. So now let's do the same thing with the second equation. Okay, so first, again, let's notice that we have y prime here, and we have 7y here. So let's get all of that under one. We'll get all that under one operator notation, and of course we'll line up our variables. We want x's under x's, and we want y's under y's. So let's go ahead and let's start with the x. So this would just be negative 4x. And now that would be plus, and let's see what type of operators have to go in here, because that's going to be operating on y. Okay, well, that's going to be y prime, so that's just d, and then it's minus 7, right? Or actually, we can write it as, let's see here. I think I actually, now that I've noticed it, when I brought that 7y to the left-hand side, I should have changed that to a positive, right? So this moved over, and that should have been positive plus 7y. Okay, so glad I caught that real quick. All right, so this would be, obviously this would be d, and now that would be plus 7. Okay, and let's make sure you understand. So d operating on y would be y prime, so that would be this. And then 7 on y would just be 7y. Okay, it's still equal to 10t. All right, so what you can notice is that operator notation at least helps us clean up our system, right? Just think of it now, you have this, just like in the previous system where you had two equations and two variables, we can now think about it as having two equations in two variables as well. Only the difference is our variables also contain differential operators. And now, let's think about if you wanted to, at this stage you'd have to choose what do you want to eliminate? Do you want to eliminate the x's or do you want to eliminate the y's? We'll choose the x's. And let's think about what we would need here, right? So let's take a look at these x variables. So clearly, I would need a positive 4, right? Because I have a negative 4 in my second equation. I would clearly need a positive 4 in the first equation. So we'll start there. But I'm also going to need a d minus 3 in my second equation, right? So we have two parts here to tackle. We'll do, so the first part is going to be multiply equation 1 by positive 4. Okay, and we'll go ahead and do that first. Okay, so in that case, you can just imagine a 4 being distributed across that first equation. Okay, and that's fairly easy. That's just simply going to be 4 times d minus 3 of x plus 16y, and now that's going to be 4 distributed to 1 is equal to 4. Okay, I'll go ahead and rewrite the second equation because we haven't done anything to that yet. Keyword yet. So of y, I'll go ahead and keep my notation, at least I'll try to keep my notation the same. And now that's still equal to 10t. Okay, so again, remember the goal is to add these two terms and to be able to cancel out the x's so that we can solve for y. So I think what you and I will agree with right now is we have the 4 and the negative 4, so that's not the problem. What is the problem is we don't have this d minus 3 notation. So I'm going to do this on the next page, but I'm going to write what we're about to do right here. So we're going to multiply equation 2 by that d minus 3. Right? Again, this is where we are distributing, but we're distributing an operation. So let me go ahead and go to my next page. And well, all I'm going to do is write the first equation. I'm sorry, the second equation, the one that we're about to operate on. So the second equation in that was negative 4x plus d plus 7 operating on y, and that was equal to 10t. All right, so as we said, we need to, what we're missing here is that d minus 3. So we're going to distribute a d minus 3 to that entire second equation. Ready? So this entire second equation all has to be operated on by that d minus 3. Okay, so even if you are ahead of me, even if you are working ahead, that's perfectly fine. Just when I tell you to take a look up from your notes, please do take a look up from your notes because there's one key part. All right, now I'm just going to go ahead and write d minus 3 operating on negative 4x. Okay, plus, then I have d minus 3 operating on d plus 7 of y. And do not forget here, if you want to look up for a second, don't forget you also have d minus 3 operating on 10t. Okay? All right, well, let's start. Let's go ahead and start with our first term here that we come through. So again, that we have the derivative of negative 4x. Now remember, the derivative is it's the derivative with respect to t, okay? So, and then we have 3 operating on negative 4x. So I'm going to go ahead and take my time writing that since it's the first one. So that's going to be d operating on negative 4x. And that's going to be minus 3 operating on negative 4x. Okay. So plus, now remember how we did this? We start here. So let's actually go ahead and do that for this one step. We'll go ahead and start with d operating on y, 3 operating on y. So we'll leave this d minus 3 here alone for just a second. Let's go ahead. So that would be d operating on y. That would be plus, did I, look at me, I keep goofing up. Do you notice it? Do you notice what I did? Maybe you didn't. So this should be plus 7. So in my anticipation, this is my d minus 3. So my apologies for these little silly errors. I wish I would say they would stop, but they won't. So we'll have to just deal with them. All right, and now this would be, let's see, we got 7 operating on y. And that's still equal to, now let's go ahead and actually do this. So I'm going to do my work down here, and then if you should probably take a look really quickly, because you're going to look up from your notes if you don't mind. So let me go ahead, and I'm going to erase this after I write it, but I want to go ahead and do my work down here. So remember this is d. Obviously it is operating on 10t, and this is minus 3 operating on 10t. But wait a minute, this is where I need you to look. How do you interpret d? Remember, we interpret it as d of dt operating on 10t. So you actually can take the derivative of, with respect to t, of 10t and just get 10. Does that make sense? And then, of course, we would have 3 times 10, which is 30, so it's minus 30t. So all of this is going to be written up top here. So this is 10 minus 30t. Okay, so I'm going to erase this clutter down here. And we're going to go ahead and keep going. So we have one more round of differential operator notation. But along the way, let's go ahead and rewrite these things, okay? So ready? Let's go ahead and go. So this is going to be, well, derivative of x is x prime. So this is negative 4x x prime. And that's going to be a negative 3 distributed to a negative 4. So that's going to be plus 12x. Ready? Now we got one more round of differential operator notation going on. So we have, let's start with d operating on, and let's go ahead and change that. So dy would just be y prime. And now that's going to be plus. Okay, now we have our d operating on, and that's 7y. And that's still equal to 10 minus 30t. Okay, so one more round of differential operator, and then we'll see what this looks like, this new equation 2. So that's negative 4x prime plus 12x. Now, the derivative of y prime is going to be y double prime. And, okay, give me 1 second here. I forgot my -3, didn't I? So let me erase now and correct this before I go any farther here. So what I'm going to do is I'm going to copy and paste this so I can make this smaller. And let's make this a little bit smaller because I'm running out of room. All right. So let's go ahead and keep going here. So in case you're wondering what happened, so I did my D operating on this y prime plus 7y, but I didn't do this part right here. All right. So let's keep going. So that's -3 operating on just y. Well, that'd be actually y prime, right? And then we're going to end up with -3 operating on positive 7y. Okay. Now that's equal to 10 minus 30t. Okay. All right. So now let's go ahead and finish up all of these operators. So -4x prime plus 12x. Well, that's going to end up being, so plus, that's the derivative of y prime is going to be y double prime. And we have the derivative of 7y. It's going to be plus 7y prime. Now this is just going to be plus, I got -3y prime. Then I have a -3 combined, multiplied to a positive 7 is going to be -21y. And all that is equal to 10 minus 30t. Okay. So again, hopefully you were able to follow me here. So remember what we were doing is we were trying to rewrite equation 2. So what we're going to do now is let me go back and grab, I'm going to underline this. I'm going to go back and first I'm going to go ahead and write what we had for equation 1. Okay, after we distributed that 4. So let's go ahead and grab that. So that would be 4d minus 3x and that would be plus 16y is equal to 4. Okay, so does it make sense that what you have here is the new equation 2? Right, so that is what's going to go here, except we want to get back to our differential operator form because that's the only way that we're going to be able to add and cancel our x's. So I'm going to go ahead and do that right now. So we end up with, let's see if we can combine some like terms and so forth. Hopefully some things start to cancel out, and then we'll go back to our operator notation. Okay. So we have, I'm going to go ahead and write any of the x variables I want to cluster together, and then any of the y variables we're going to cluster together. So this is going to be negative, so we got -4x prime plus 12x. There's no other x's to combine. And then we can combine this 7y prime with this -3y prime. So we can, that's going to end up being plus y double prime. Well, 7 minus 3 is 4, so plus 4y prime. And then minus 21y. All right, so I kind of already showed you by writing where that first equation where we're going to need to go. So at this stage, let's go ahead and get this back to basically our differential operator form. So let's go ahead and let's go ahead and write that. So now we're going to have. I think I'll give myself a new page. You're starting to see why diffeq can take forever, right? All right, and let me go back and I'll grab that first equation as well. Copy. And then I'll have to erase some things here. All right. All right, so can we get back to differential operator form? But more importantly, do we understand that, so there's a couple ways you can go with this. Do we understand that at this stage, we multiplied by the top equation by 4 and the bottom equation by our d minus 3. So what should happen is at this stage right now is when we add, this part should zero out. That's the key thing to understand, okay? And so let's just go ahead and do it this way. Maybe this will be easier. Sometimes I have to change my mind. So I want you to make sure you understand that the x's are going to cancel out at this stage right here. So let me write. So it's negative 4x prime plus 12x plus y double prime plus 4y prime minus 21y is equal to 10 minus 30t. Okay. So let's go ahead and you would have a choice. You either can to see that this is going to cancel out. So we have our top equation is in differential operator form. The bottom equation is not in differential operator form. So either you get the top equation out of differential operator form so that you can see that it cancels, or you place the second equation in differential operator form. Either one is fine. I think what I'll do for our purposes is get the top equation out of differential operator form, just so you can see this works. So what we would end up with is positive 4x prime, and that would be minus 12x. Okay, so out of differential operator form. So that would be plus 16y, and that's equal to 4. So now you can see that when we add, right, so finally when we add, we end up with our x's zeroing out. So we have 0 plus, and let's go ahead and see what's left here. So the only thing to combine when it comes to our y's is our 16y with our negative 21y. So this would be y double prime plus 4y prime. And now that would be, what do we got, minus 5y. And that equals, well, now let's add the right-hand side of the equation. So we have 4 combined with 10 to get 14 and minus 30t. Are you with me? Are you with me on where we're at in this problem so far? All right, so what I want to do is I want to go ahead and take a break. And I understand that I'm taking a break in the middle of a problem. But it's, as you can see, this is quite involving. So I want to go ahead and take a break with where we're at, because you kind of what do you normally do? Once you've solved for y, you normally plug it in back in and then solve for x, right? So the real question now is, well, how do we get from here to a solution of y? And I'm gonna decide to take a quick break, and then we'll come back and we'll finish this problem.